Okay, so I want to talk about functions, rational functions, I should say, that have oblique asymptotes. And remember we said an oblique asymptote, so there's vertical lines, horizontal lines, and then if your line is not vertical or horizontal, then it's called an oblique line. So those are the kinds of asymptotes that we're going to look for. Now, in order to get an oblique asymptote, remember the degree or the highest power on top. So the degree in the numerator must be exactly one more. So degree in numerator is exactly one higher than the denominator. And that's it. It has to be exactly one. If it's 2, it doesn't count. It has to be exactly 1. So degree in numerator is exactly 1 degree higher than the denominator. And so, if that's true, if the degree is exactly 1 higher, then you have to use long division to find that oblique asymptote. And I know that some people moan and groan about long division, and it's a little tedious, but it's not too bad. But then some of you might also know synthetic division. Synthetic division won't work here, but I will remind you and revisit synthetic division when we solve for solutions. But synthetic division only works if you have linear factors. If you have quadratic factors or higher, that then the algorithm of synthetic division does not work. So here is a function. We'll just do a quick example. So here is a function. Just a couple off the top of my head, like 2x cubed plus 3x squared plus 4x plus 5 all over maybe, let's say, x squared plus 2x, okay? This has 1 degree higher in the numerator than the denominator, right? Because remember, the degree refers to the highest exponent. This is a 3, this is a 2. So because the top is exactly 1 more, we know that there's going to be an oblique asymptote. So how do I obtain that equation? Through long division. So that's this part I'm going to review. So I'm going to take this part that's in the denominator, and I'm going to divide it into the numerator. And so then that's 2x cubed plus 3x squared plus 4x plus 5. Now, this is just, again, a review. Remember, and some of you may remember this, and it's great. Some of you may not, and that's okay too. So you look at the lead term and the first there. So you think about x squared times what number would achieve 2x cubed? And so if you take it times 2x times x squared will give you 2x cubed. 2x times 2x is 4x squared. Now here's where you have to be careful. I'll even highlight this because you are subtracting. You're always subtracting, so be very careful. So then 2 minus 2 is 0. It's the whole point. You want them opposites. So then 3 minus 4, that's where you're going to get your a value -1. So then negative x squared, and then you bring down your plus 4x. You can bring down your 5 too, but there's only 2 terms, so we can hold on to it for the next time. That's fine. I have mine as well. Okay. So then you say, okay, well, how many times does x squared go into negative x squared? So we can say -1. So then we repeat. So 1 times x squared is, negative 1 times x squared is negative x squared. Negative 1 times 2x is -2x. And remember, we subtract. So you're subtracting that because you want them to be opposite. So negative minus negative is a positive. It cancels. That's the whole point. 4 minus -2 actually becomes 6x plus 5. Now, once this value here has a smaller degree than this, then you can't divide anymore. And another indication is look at your numerator, right? It's 2x and then the constant, there's nothing left. So the original function is equivalent to 2x minus 1 plus a remainder of 6x plus 5 when divided by x squared plus 2x. So I could say that function is equal to, which I called f of x. So an equivalency is f of x equals 2x minus 1 from the top plus the remainder of 6x plus 5 when divided by x squared plus 2x. So now that the degree in the numerator is smaller than the degree of the denominator in this, in this part of the function, that part's in proper form. It's in reduced form, and here's the part that now becomes our oblique asymptote, right? Yellow here, right here. Okay, that part, the part that's up here, the part that has a whole number, or not whole number, but that evenly divides. Okay, that's your oblique asymptote, right there. So up there, and I'll maybe even write that in green, oblique asymptote. And remember, it's an equation, so it should be like y equals. So my equation is y equals 2x minus 1. Now, what does that look like, 2x minus 1? So I would just draw a dotted line, and that at infinity, or the endpoints, the graph will start to look like that diagonal line. Now, this remainder that you see down below, this is, it is linear, but it is not the oblique asymptote. This is just the remainder. So I want us to kind of keep track of that. So that's just the remainder. Okay, so that was just a practice example of long division. And like, we're going to do lots of examples. So like here, it says find the equation of the oblique asymptote or state none. Well, I know by inspection, since this degree is 2 and this degree is just 1 degree higher on the top. So yes, I know that there's an oblique asymptote. How do I find it? Through long division. So x plus 4 divides into x squared minus 2x plus 6. So x goes into x squared x times x is x squared plus 4x. Don't forget, remember, we subtract, so I'll highlight that in red. Don't forget to subtract that. And so then, so then we get x squared minus x squared is 0, negative 2 minus negative 4 becomes negative 6x, and then you bring down your 6. And then we do it again. So then you think about, okay, so x goes into negative 6x, negative 6 times. Negative 6 times x is negative 6. Negative 6 times 4 is negative 24. And then don't forget, one more time, we subtract. So negative 6 minus negative 6 is 0. And then 6 minus a negative 24 actually becomes plus 30. Remember, the oblique asymptote is sitting up here. The remainder is here, it's 30. So the remainder we're not really worried about right now, but I am interested in the equation of the oblique asymptote. So then I will write the equation. I'll use this nice blue. So y equals x minus 6. So the function will start to behave like this linear function. So, and you would just graph this as a dotted line, like negative 6 intercept, and you would just draw this oblique asymptote. And again, remember, the whole point of an asymptote is that it predicts the behavior of the function. So apparently this graph will start to behave like this linear function going, kind of across the xy coordinate system. Okay, so I'm going to end this first video, kind of let you process that, and then we'll continue to do 2 more examples. Feel free, if you want to try the other 2 examples before you watch the video, and then you can watch to see if you did them right.